This video is on Unit 2, Chapter 5 on solving quadratic functions, lesson number 1, solving quadratics by graphing. So the whole focus of this chapter is solving quadratic functions. We know from the parent function chapter that the quadratic is the f of x is equal to x squared, and the graph was the parabola. Okay, so that's the parent function that we studied. And what we're going to do again here is we're going to focus on the solutions. So let's talk about the solutions to a quadratic equation. The first bullet says the solutions to a quadratic equation are the points at which the function intersects the x-axis. So we're talking about where does it hit the x-axis. The solutions are not just referred to as solutions or answers. They're also referred to as the zeros, the roots, or the x-intercepts. You might hear me call them any one of those names: solutions, answers, zeros, roots, x-intercepts. As you're reading directions on EOC or ACT or anything like that, you may see any of those words, and they all mean the exact same thing. Where does this function hit the x-axis? Now, there's three different things that can happen here. When we talk about numbers of solutions, there are three things, again, that can happen. The first one in your notes here, and I've got the two covered up, is that you might have two solutions. The parabola is going to hit or cross the x-axis two times, creating two solutions at those points. Again, where it's hitting the x-axis. Your parabola may only hit the x-axis one time, giving you one solution. And then the last situation is there may be a situation where the parabola doesn't hit the x-axis at all. Now, in Algebra 1, we call that no real solutions. But in Algebra 2, what we're going to learn is that we have two complex solutions. Now, we're not going to worry about what those complex solutions are in this lesson, but we will in the next lesson. So for now, when that happens, when you're solving by graphing, all you have to say is no real solutions or two complex solutions. And I would actually prefer you to say two complex solution, because that's going to let me know you really do have a great understanding of what's happening. So the directions here say to find the solutions to each quadratic equation by graphing. Now, we are not going to do graphing in the sense of the word of graphing on paper. We are going to use our graphing calculator to find the solutions here. So the first thing that I want to do is on question number 1, it says f of x is equal to x squared plus 2x minus 3. We have to take and put that into the y equal. So get your calculator, go to y equal, and we're going to put in that equation. X squared plus 2x minus 3. And then we're going to hit graph. Now, you can easily see we have two solutions. The parabola comes down and it hits the x-axis twice. And it looks to me like -1, -2, -3. It looks like it's hitting at -3 and a +1. Well, I want to make sure that that's actually the case. So I'm going to look at the table of ordered pairs. What's happening at -3? Let me jump in my table so I can get to -3 pretty quick. So we thought it was at -3 and a +1. And if you look at the -3, the key here is that the y value is a 0. And at 1, the y value is a 0. Those are my two answers, -3 and 1. And I'll explain why. We said earlier that the solutions are also called x-intercepts. At the x-intercept, the y coordinate is 0. Again, at your x-intercept, the y coordinate is 0. So when I was looking at that in my table of ordered pairs, At -3, I know it definitely is the answer because the y value is 0. And we only use the x because we're solving the equation. What does x equal? You're solving it, but you're not solving it like you would a regular equation. It's a quadratic. So you have to solve it by finding out where does it hit the x-axis. So x is equal to a -3 and x is equal to 1. Number 2, f of x is equal to -x squared minus 10x minus 25. Again, we're going to put that into y equal. I'm going to clear out the old -x squared minus 10x minus 25, and then I'm going to hit graph. Now, this one hits one time. This one has just one solution. Just one solution. So where does it hit? Looks like at -5. Again, I'm going to confirm by looking at my table, scrolling up to where x is -5, y is 0. So for sure, my answer is just -5. Number 3, again, we've got x squared minus 6x plus 8, y equal, clear out the old, x squared minus 6x plus 8, graph. This one, again, looks like it has two solutions, 2 and a 4 maybe. Let's double check. What's happening at 2? Y is 0. What's happening at 4? Y is 0. So my two solutions are 2 and 4. Let's see what else we got. Let's look at number 5 real quick. X squared minus 9. Now, what you're going to notice here on this one is that there is no middle term. Typically in quadratics, you have ax squared plus bx plus c. So there's your quadratic term, which is the x squared, and then you've got your linear term, which is the bx, and then you've got the constant. So what you're going to do at that point, because on number 5 it doesn't have a bx, it's not that big of a deal. The calculator's doing all the work for you. I just wanted to make sure you understood here that number 5 doesn't look like the others, but it's okay. We can just put in the x squared minus 9, and the calculator is going to take care of it. Two solutions. Looks like a -3 and a +3. Again, we're going to confirm. -3 is a 0, +3 is a 0. So my two solutions on this one are a -3 and a +3. And I'm going to write that like that, indicating that there are two solutions. One's a +3 and one's a -3. Let's look at let's jump down to number 6. Same thing. Again, if you notice here, it says 2x squared plus 6x. It has the ax squared and the bx. It doesn't have a c, which again is not a big deal. The calculator is going to do all of that work for you. Not worrying about that one. Number 7 says f of x is equal to -x squared plus 8x minus 17. Going to my y equal, clear out the old, -x squared plus 8x minus 17, and let's hit graph. So what you should see here is that the parabola is not crossing the x-axis at all. So what that means is that there are no real solutions, but we have two complex solutions. So you can either say no real solutions or two complex solutions. Again, I'm saying to you, I would prefer you to tell me that they are too complex. All right, so those are your notes for this lesson. Again, this was lesson number 1 for chapter 5 on solving quadratic functions. And we will work on the assignment in class.